I'm Nadia Rosenthal. I'm currently the scientific director at the Jackson Laboratory in Bar Harbor, Maine, and I was at EMBL as the unit head for the EMBL Rome here in Monterotondo from 2001 to 2012.
So what led you to the EMBL, and especially coming from overseas, a different sort of scientific environment?
I had spent quite a bit of time at EMBL Heidelberg because my best friend is Anna Frusi. I have known her since we were both at Harvard together as undergraduates, and we have been friends for many, many decades. And when she moved to EMBL, she wrote me and said, "This is the most extraordinary environment you can imagine." And I had visited her on many occasions in Heidelberg. So when I was introduced to my current husband, Alan Sawyer, by Anne in Heidelberg, I had no idea what was going to follow, which ended up with Alan moving to Harvard, and where I currently was a faculty member, and convincing me that after several years in America, he really wanted to get back to Europe. In the meantime, I had had a couple of different invitations to look at positions, specifically in Italy, also in Germany. And one of them was a invitation from Fotis Kafatos, the Director General, who I actually was a graduate student with back when he was at Harvard. So I knew him very well. And I remember he took me up onto the Philosophenweg and said, "You know, you really should think about moving to Rome." And my parents had lived in Rome before, so when I was an undergraduate in the UK, I had spent some time in Rome, so I knew what I was getting myself into. I ended up looking at the job, and he gave me 24 hours to make the decision to move.
Wow.
So I said yes, because I love taking risks, and it was a great risk.
Yeah, I mean, and actually, I think in retrospect, this was quite an undertaking, right? Because this was more or less shaping up or, restarting perhaps this site where we are today for the EMBL 25th anniversary of EMBL Rome, right?
25 years later. Yeah. Yes, it was an undertaking to come here. We were very lucky to be able to learn from Klaus Rajewski, the previous center head here, that he had an apartment in Rome that he and turned over to us at that point. And we moved here with the expectation of support from the central headquarters in Heidelberg, much of which I had been misinformed about, and there was a real tight budget to meet. Furthermore, there were only about 3 or 4 groups, one of which was Klaus's, and I remember there was about 40 people working here, so it was really small, and we had to decide how we were going to build it on very little money. Furthermore, there was no mouse house. We had been promised a mouse house, but that never materialized, so we had to come up with a way to take this money out of our own budget to build a new mouse house.
Wow.
So that was a very interesting undertaking.
Almost an impossible task. In low budget, having to expand, but still having, not a big...
Yes, it was a very, very daunting task. However, my secret weapon was the site manager, Emilio Metocha, an amazing guy, unfortunately no longer with us, but at the time, I would go to his office and I'd say, how are we going to do this? And in Italian, and he would say, "Vediamo," which means we'll see. And "vediamo" became the buzzword for how this place grew. We just came to it and looked at it and said, "Vediamo," and we came up with a way to do it. And between the two of us, I think we came up with a really innovative solution. Yeah. Very low cost. And we built a beautiful mouse house, which I understand is still working perfectly well today. Okay.
So there's something, that I find curious, because I always thought that from the beginning this was a site devoted to mouse biology, but you're saying that for at least a few initial years, there wasn't a mouse house, so it must have been very
Well,
difficult
yes.
to do mouse biology, right?
It was. We had converted a few of the labs into mouse rooms, but this, of course, is suboptimal because of the health issues, and we needed to have a separate and contained environment for mice, and this was why we were so anxious to build the mouse house. Fortunately, we had Emma next door, the European Mutant Mouse Archive, and they were very helpful and actually housed some of our animals while we were in this transition period to try to find a way to build a mouse house.
Cool. So, and then tell me a little bit about the science. I mean, did you have in mind, beyond your own science, of course, a direction for the mouse biology science of the site, or you were, more, bottom up and saying, okay, we'll hire good people and then the science will come? How did it work?
When I came here, I had always worked in very specific areas in departments at universities. So I was at Harvard Medical School, then I went to the Boston University Medical School, then I went back to the Mass General as part of Harvard Medical School. And in each case, I was moving from one cardiovascular department to another because I had decided that my interest was the heart, among other parts of the body, but this one was the current interest. And when I arrived at EMBL and I spent time looking at the way Heidelberg was operating, I realized a couple of principles that I really, really wanted to follow here. One of which was that the core facilities were absolutely critical. If you're having small groups and you're trying to foster good science from very, very early career researchers, the best way to do that is to provide them with the expertise in each one of the more technical aspects of their work so that they don't have to build a huge group which actually duplicates a lot of what's going on next door, and rather centralize the core facilities with people at the level of faculty running them who are innovating all the time. And this, of course, is one of the hallmarks of the success story that EMBL has enjoyed over the last 50 years. So I wanted to do the same thing here, which was not easy, but I think we were very much helped by Heidelberg and by the other outstations to try to supplement what we couldn't do. And that allowed us to look at a number of different areas of research, not just cardiovascular. I had no interest in building another cardiovascular center. I didn't see any reason for that. Instead, what I wanted to do was to make the mouse the centerpiece. The idea of having the mouse as a paradigm for human health and disease, and the idea that not any one organ system is working in isolation, but has to rely on a whole panoply of different functions that are all interrelated. So my idea was simply to hire new group leaders that had that same mentality. They were interested in one part of the mouse, but they saw this as an organismal center where we could understand better the interaction between different areas of physiology and genetics and biology. And we were very lucky to get superb people. Some of them were already here when I arrived, and then we hired a number of others, one of whom is now the acting unit head here, Cornelius Gross, an amazing scientist who I'm very proud to say I was part of the recruitment. And here is a case in point. I mean, he's a neuroscientist, and yet we had many interactions about what we were looking at. Klaus Nerloff, an amazing immunologist. He and I started publishing right away because we suddenly realized that, of course, immunology is everywhere in the body, and the heart is susceptible to immune interaction, and so therefore I started learning immunology from Klaus so that I could understand what I was looking at when we were looking at diseases. I remember one of our first unit reviews. It was pretty scary. Paul Nurse was the chair. Then we had Scott Fraser, who is outspoken, and a number of other luminaries who showed up and questioned our approach. And I remember very clearly one of them said, "You're too small to have so many different disciplines going on." And without thinking, my response was, we're too small to concentrate too much, because we'll never be able to compete with a neuroscience department at Stanford or, another immunology department at Max Planck. We're not big enough. So we have to come up with something that actually speaks to our strength, and our strength is the mouse. So if we manage to interact with each other, then every time we perturb a gene that has an effect we think is going to have an effect on the kidney, and instead it's having an effect on the liver, we have someone down the hall that knows about liver. And I convinced them that this was okay, and they let me do it for the next 10 years. And so as a result, you see what we have now, which is a group of people who are interacting very closely, and that's the most important.
Yeah. So, I mean, I think, you know, I mean, it's very forward-looking because, I mean, I'm not a mouse biologist myself, but I think, you know, the investment is so much in terms of time to build the genetic backgrounds, and actually what you referred to, in fact, you know, finding phenotypes that sometimes have to be searched for. And so this idea of having a centralized set of facilities that could streamline the kind of groundwork for building the models, phenotyping the model, I think it was very forward-looking. There are companies now that are doing the phenotyping if you're looking for a phenotype that is not there. So that's really interesting. And the site I've seen is growing. It went through several transformations, but I think it's great that you know, it's still one of the major places in Italy where mouse biology has been done. So was it, I mean, I have a curiosity mostly. I mean, you know, there's, you know, mouse biology involves a lot of regulations from the ethical standpoint. The society is usually reacting to that. I mean, was it difficult to set up from the societal point of view? I mean, did you have pushback because you were using mice?
That's a great question. How to reconcile the public concern about animal research with the realities of animal research. I have a lecture that I give quite frequently about this, and the points that I make about it are that, first of all, if appropriately and ethically conducted, animal research is much, much less stressful on an animal than, let's say, a mousetrap or a poison, which you can buy in the supermarket. And yet the animal rights people are targeting scientists who are much more interested in the welfare of the animal and the health of the animal. Although I am an animal lover, and I'm a particularly mouse lover, and I have deep respect for this animal. They're unbelievably smart and unbelievably reminiscent of some of the behaviors we see in ourselves. Nevertheless, there is a limit to which we can understand the full physiological effect of an infection, let's say, or a disease in a whole organism, simply extrapolating from cells in a dish, which of course is now what everybody wants to reduce biology to this. And of course, we are using mouse cells in the dish because the less mice we have to kill, the better. And furthermore, we can then equate the mouse work that we're doing in the dish with the human work that's being done in the dish. And hopefully that will actually knit the two areas together. But ultimately, I feel that if done correctly, nobody would actually object to the way in which these animals are treated with, you know, great respect. I am particularly vehement about animal welfare. And so I spend my time in the animal houses that I run to make sure that people understand the privilege they have when they're using an animal as a research tool. That said, I have to tell you that Italy was not a hard place to do mouse research. Italians are quite practical, and they don't have quite the same overbearing concern about animals. It's an agrarian society, and I've also worked in Australia where the same practical aspects are there. And so we actually had very little problem here. A few interactions with PETA and some of the other anti-vivisectionist groups, but I think that mice are unfortunately seen half as an animal that you should protect and half as an animal that you want to eliminate. Yeah. So we have a little more freedom to operate. Not that I think that's a good thing. I think freedom to operate then requires responsibility.
Yeah, of course. And I mean, you have been, using that model system your whole career, so it was better to reflect on that and also to direct on that. I mean, related to that, another question that I had is the role of mouse biology going forward. I mean, we have seen the Kafatos lecture a couple of weeks ago, and of course the speaker this year was Hans Clever, which was all about organoids and these, systems that, promise to replace some of the in vivo organismal biology. So what's your view on that? I mean, how do you see that the mouse biology still has some mileage, or perhaps you're switching yourself to some of these approaches?
I don't see why we have to choose. And in fact, I think the point is not to choose and actually to use each system for what it's good for. And I'm excited about organoid research. I have an enormous respect for Clevers and others who are really developing these diversity in a dish type of micro tissues. You can certainly dissect certain cell-cell interactions much, much more easily in a dish than you can in an animal, where you have to kill the animal or invade the animal in order to understand what's going on. But I think ultimately it's going to be very difficult for the translation of the research that we do, whether it's in the dish or in molecular terms, directly into translation into a drug without some safety tests. And I'm very concerned about what's happened recently in the United States, where the Food and Drug Administration has lifted the necessity for an animal test for drugs, so that in theory you can go directly from a human cell in a dish, a human organoid in a dish, to a drug for a patient. And my concern is that inevitably there will be a problem. We've seen this over and over again. There's always problems with translating into humans. And what would be a particular tragedy would be if something happened that would be so unfortunate that it would set science back, the way it did on several occasions when aspects of our work in, for instance, viral therapeutics backfired.
Yeah,
so we want to try not to have that happen again for very practical reasons. Otherwise, we get shut down.
Yeah.
And so I think the work that's being done in multi-cell organismal type of organoid research is fantastic, and it's fascinating. And I was just yesterday in the lab of one of my ex-postdocs, who's now at Rome La Sapienza, Antonio Musaro, who has the most extraordinary results with organoids and looking at muscle and heart. And I'm super excited about this. So there's no reason to choose. We should use everything we have, including machine learning and artificial intelligence, to extract information that we can get more easily if we have a more limited system like a microtissue or an organoid.
So coming back to the EMBL, after the EMBL Rome years, you remained as part of the community, and you actually took on a very even more challenging project, which was the one of starting an institute across the world in Australia, or a site for the EMBL. So can you tell us a little bit about that story?
When I started at EMBL in 2001, Fotis Kafatos was the Director General. I knew him very well, and we had long discussions about what the future of EMBL was going to be. And obviously at this point he was very excited about expanding the member states. And he did, but he was also intrigued by the concept of taking the EMBL model and exporting it to non-European and maybe distal sites. Mm-hmm. Singapore was his first target. He thought Singapore would be a great addition. I spent a lot of time in Singapore as his emissary to try to convince the leadership there that they should definitely become an associate member of EMBL. And I got nowhere with these guys. They had their sights set on Cambridge and Oxford. They had that all set up, and that was their conduit to Europe. They didn't need any others. So I came back to Fotis and I said, I think you need to get creative here if you really want to do this. I invite you to fly 4 more hours from Singapore to Western Australia, where I had connections because of my work and the university there. They are interested in looking at the possibility of Australia as a potential member state. So he did. He and Sarah, his wife, flew in 2004 from Singapore to Perth. I had it all set up for them. The university laid out the red carpet. They explained how everything works in Australia. I took him on a tour around Australia. He has many friends there anyway. By the end of it, he said, this is perfect. They have obviously a great deal of enthusiasm for EMBL. They know it well. They're also kind of like Europe before the European Union, very competitive member states against each other. And they do. Each state, Western Australia, South Australia, they compete for funds and they compete for reputation in science. And he says, this is good. This is actually going to work in our favor. So I said, okay, if you want, I'll try to start it off. And the place that made the first move was in Melbourne. And they asked the very, very luminary and visionary Vice Chancellor at the Monash University, Edwina Cornish, said to me over a coffee one morning, let's just do it. I thought this is exactly the mentality that EMBL likes. So we set up an institute, Australian Regenerative Medicine Institute, which was my field at the time. And I said, let's make this the model. And into this we can put group leaders and see how it goes. And that's how it started. And without going into too much detail, now there are, I think, 20 group leaders spread out all over Australia, with more coming in from overseas, because of course everybody wants to come to EMBL in Europe, but there aren't so many places. And the same system is set up in Australia, where you have 5 years of funding with another 4, and then you have to leave. A slightly different setup because each member state is a state, but the money is coming for the membership from the whole federal system. But with those small differences, I think the country has adapted very well. And what's happening is that the new group leaders in Australia are leading by example. This is how to do it. Don't fund the old guys like me. Fund the young ones. Fund the ones that are going to be the future of your research. And this was not the way the Australian mentality had been before. So I think we made a big change for them. And I'm hoping that will persist.
So I think, you know, in reflecting on this, I think the aspect that I like a lot is the aspect of starting careers, right? Because I think one of the biggest values of the EMBL is training scientists and junior scientists. And so I like this idea that now you say that the institute is somewhat distributed, because then you get the support, but you are providing the example on not on a single site, but on very different sites, which I think, you know, is it works at the site level for the EMBL galaxy, let's say, but this has been done, you're saying, at the, you know, single group leader level. So it's almost like planting a few seeds that will bloom.
Well, yes, and unlike something like the Howard Hughes, where single group leaders are inserted into universities in America anyway, in this case, I insisted on an EMBL outstation type of organization so that there would be critical mass. Otherwise, people feel sort of isolated. You know, it's a different feeling if you only have 9 years in your job. Nobody stays for much longer than that anywhere, but somehow that cutoff is it's inspiring to take advantage. Don't spend too much time competing within your organization. Compete with the world, because that's where you're going to end up in 9 years. Yeah. And this means that people tend to coordinate with inside. They collaborate very well inside because they have nothing to fight for each other for. Everything is the same. You get the same package, but you know you only have 9 years to use it. And I think it's an enormous incentive to do very, very innovative work, because you know you'll probably never get this deal again. And so I find that that's what is so exciting about EMBL and the way in which they form real sort of incubators for talent. And I'm obviously a big fan.
But if you look at the other way, it's also very interesting, because I mean, let's imagine that the EMBL is not an institute, but it's let's say a starting career grant. I mean, this would be very generous, because it's a long starting career grant, and it's a starting career grant which is integrated in a community of scientists with common facilities, with sites that they can do. So I think it would be almost, you know, I guess, you know, the EMBL would not see it that way, but it's almost like having the best startup package that you can have on the planet.
I think it is definitely the best startup package that you can have at the planet. And now that I'm at the Jackson Laboratory, I am secretly turning it into EMBL USA. Just don't tell anybody. So
the next adventure. This was actually my next question, because then after, you know, jumping on the other side of the planet, you came back sort of full circle, not really exactly in Boston, but I guess nearby, to take up a position at the Jackson Lab. So tell me a little bit about that, because I have to say I'm not very familiar, not being a mouse biologist. This I've seen almost as a provider of mouse strains. So is it, you know, industry, is it academia, is it something in between, and what do you want to make of it?
Well, it is. It's a very interesting place, and it attracted me for that reason. I had become very excited about a group of people in Australia who were using non-canonical mouse models to mimic the genetic diversity of the human population and try to understand why some people are very sick with the same mutation where others are not, or some people can eat, you know, endless bad food and remain very, very fit, and others get diabetes for no reason. What is going on there? Obviously, lifestyle plays a role, but there's also a significant genetic component, and with mice, you can prove that because each mouse strain has an inbred component to it which doesn't change from animal to animal. So if all the animals get cancer or all the animals get heart disease, you can be pretty sure that this is because of the actual genetic makeup rather than the food, because we're feeding them all the same food. And I was very interested in the way the heart attack that hits people in different ways can kill one person and another walks away, because I was working on the heart and regeneration of the heart. And what we discovered were these different mice had completely different responses to a heart attack. And I was very hard pressed because we had all these different mice that we needed to work on, but one was here and one was there. I had to call people in Western Australia and they didn't have enough, and one thing and another. And then I realized where all these mice were coming from. And so it was a bit selfish, I know, but I thought if I'm really going to be able to understand how to develop drugs, I'm going to have to use mice like this if I want to stay in mice. Yeah. So that's why I moved. I moved for the mice.
I think, you know, selfish for scientific progress is a good way to be selfish, I would say.
In any case, it was a wonderful new opportunity for me at a time in my life when I wasn't expecting to move again.
No, so that you know, it was a great you know, conversation. Let's maybe close by you know, asking you what EMBL has meant to you and what you see about the EMBL relationship going forward.
Well, EMBL has meant the world to me because when I left Harvard to come to EMBL, I had never experienced the kind of freedom, both intellectual and practical, that we have here. I was also very excited to run my first institute. It was probably the most fun, was actually pulling people in, finding people who really wanted to join. And that's pretty infectious when you realize that you can change someone's life by offering them something like an EMBL group leader position. So that has kept me in the administrative world because I can't get it out of my head that if I have some access to funding through directing institutes, I can actually find people's best career choice and help to monitor that and to foster that. So none of this would have happened had I stayed at a regular university where, frankly, you're hanging on by your nails. And the idea that there is a place in the world where science is free to operate and to also attract the most talent and give it the best opportunity to succeed is very, very compelling. So I would say that I've been bitten by the EMBL bug, and I probably will be infected with it for the rest of my life.